everyone. Let's begin. My name is Kai Trong, and I am here to introduce Ron Baecker. So it's my pleasure to introduce him as today's Tux Member Talk series speaker. Ron is Professor Emeritus here at the University of Toronto. He joined us here in 1972 after earning his PhD from MIT in 1969. And since then, he's really helped to establish U of T, and in particular the DGP lab, as one of the top places in the world to do HCI research. I'm only going to mention a few of his accomplishments because this list is very, very long. In recognition of his accomplishments, Ron is an ACM Fellow. He has been named as one of the 60 pioneers in computer graphics by the ACM SIGGRAPH community. Has been elected to the Chi Academy by the ACM SIG Chi community, and has been given the Canadian Human-Computer Communication Society Achievement Award as well. When reflecting on Ron's accomplishments, personally I would point to three things that I think Ron has accomplished that I think are especially meaningful. The first is that a lot of the academic lineage of many of the researchers in our field point back directly to the man, right? And many of the people sitting in this room are also academically related to Ron in some way. The second is that Ron is a builder. He helped to direct the DGP lab for many years. He helped to found the KMDI Institute. He helped to find the TAG lab. And out of these different labs and units, a lot of great research in the field of HCI was able to happen and occur. And then thirdly, Ron has written a lot. He's published over 175 papers and articles on various topics in human-computer interaction and user interface design, user support, software visualization, multimedia, computer support, cooperative work and learning, etc., etc. And this includes, of course, 4 books, one of which I remember reading in the early 1990s as a young student myself. Right, and so he's now working on his 5th book, and you get to ask him a little bit about that at the end of this lecture. But my point here is that Ron is really an authority when it comes to the field of HCI and his message about human-computer interaction, which makes today's talk about AI and HCI and sort of how the two have opportunities to benefit from one another especially meaningful. So with that, I'd like to ask you to help me please welcome Ron.
Okay, thanks very much, Kai. When I think back to arriving here in 1972, we didn't have a lab. We had a computer graphics display. I won't name the manufacturer, but some people used to joke that this manufacturer, who still exists in the computer industry, gave us this to hold us back in computer graphics. In 1974, as we got our first real lab and our first real display, a vector display known as the Graphic Wonder, and had the first incredible bunch of students. I'm trying to see if any of them are in this room. Yes, Hugh, but also David Tilbrook, Mike Tilson, Tom Duff, Rob Pike. I'm probably forgetting a few.
Bill Reeves.
Bill Reeves, yes, the first computer scientist ever to win an Academy Award. I decided we needed a name for the lab and came up with the name Dynamic Graphics Project. So that's where the name DGP comes from. So I'm going to talk today about AI. I'm not an expert on AI, so if there are experts in AI in this room, you can correct me if I malign the field in any way. Where this talk comes from is, as I look back in my career, and you can see the areas I've worked in because I'm a bit of a dilettante and I never stay in one place for too long. I've worked in a number of different fields in computer science and computer applications. And in fact, as early as 1971, 72, before I came to U of T, when I spent a year at the University of Maryland, I actually taught a course on computers and society. Probably was one of the first such courses ever taught. And when I came to U of T, I didn't continue to do this because Kelly Gottlieb had been doing it for some years and was doing it very well. In those days, in the 70s, people were starting to think about social issues that arose in computerization. The topic that engaged people the most was the topic of privacy, because at that point there were concerns about government databases and all being linked together with universal ID numbers. And if the people who were worried about that in those days were alive today, and some of them are, they'll be staggered at the extent to which issues of privacy are no longer driven by government, but driven by certain corporations and by our desire to share everything and to tell everybody everything about us online. And the other issue that concerned people in the 70s was AI, and there was a well-publicized debate between Seymour Papert, one of the AI pioneers at MIT, and a Berkeley philosopher named Hubert Dreyfus about the limits of AI. The very famous books by Dreyfus, What Computers Can't Do and What They Still Can't Do, and a rebuttal by Papert called The Artificial Intelligence of Hubert L. Dreyfus, et cetera, et cetera. And most of these debates dealt with could computers think, and what did this mean to human identity, et cetera, et cetera. Anyway, to go back to myself, if you look at the fields there, I get bored with something about every 7 years. And so I decided that it was time to do something new. And in great part because of what was happening in AI, and I'll talk about some of this in the talk today, I decided to look at computers and society. And I looked around to see if there was a good book available. I've started some companies and one learns to do competitive analysis. This was no different. If there was a dynamite book at a reasonable price, why should I write another one? But in fact, there's not a dynamite book at reasonable price. There are two books, one in their 7th edition, one in their 5th edition, which are workmanlike and whose structure and table of contents was probably appropriate when the books were first designed 15 to 20 years ago, but they're no longer appropriate for the field. And on top of that, they're published by a publisher who charges outrageous amounts of money. And so I decided that I would do my own book that would deal with digital technology at all scales and talk about social, political, legal, ethical, moral issues. And of all the issues in my book, and this talk is not directly an advertisement for the book, of all the issues that seemed to be the most compelling, the most pervasive, the most important, and to some extent the most scary, was AI. And that's the topic of chapter 11 of the book, and that's what I'm going to talk about today. And so the outline of the talk is I'm going to talk a little bit about AI and then a little bit about intelligence. And then I'm going to propose some reasons why I believe current AI is not intelligent. That in many cases it tries to fool people into believing that an algorithm is equivalent to a person, that it's not self-aware, open, and explainable, that it's not trustworthy or capable of being responsible, that it's not empathic and not assuredly just. Now, these are very strong assertions, and I don't believe that I'm going to prove them in any deep sense today, but I want to at least get you to start to think about the issues, because in fact there are a number of thoughtful people in AI who are concerned about this as well. And I believe that this represents opportunities for HCI research, that in part what's required is new interfaces that bring people into the equation in various ways, not only in terms of the design, testing, and evaluation of intelligent agents, but in terms of agents that involve some human in the loop. A good example is self-driving cars. It's widely talked about that, of course, at least for a while, self-driving cars are not going to get us into trouble because people could suddenly step in and take control if the algorithm goes wrong, and that's I mean, to some extent absurd, because in most cases someone sitting there, if there's a need to step in, that decision has to be made in a split second, and the person is not typically in a position to step in time. It's a little different on an airplane, where the object you might hit might be minutes away, and so there's time for the pilot to get more alert. So there are issues even there where HCI is important. So let's talk a little bit about AI. What's really caught the public's attention is the incredible achievement in game playing. So checkers program became the best checker player in the world, I think in the late 70s or early 80s, a man named Arthur Samuel at IBM. Chess, Kasparov held his own against Deep Blue, no, not Deep Blue. Yes, it was Deep Blue, I guess. Kasparov held his own the first time he played in, 87. 86, but then in 87, and I attended one of the games in New York. Deep Blue beat him. Jeopardy, IBM developed based in part on the marketing advantages they saw from the defeat of Kasparov, took on Jeopardy and beat the two reigning human Jeopardy players about 8 or 9 years ago. Go fell to a computer about 2 or 2.5 years ago. And what's most amazing, and again, I mean, I'm in part, I'm a technological gee whizzer as well. So this is amazing. What's really most amazing, and shortly after that, another program that played Go learned how to play Go on its own without having seen anything, without having been trained with examples, and then beat the world's best Go player, that other machine, all funded by Google. And poker, which has been tackled and won by researchers at the University of Alberta. What interests me, since my game is bridge, is why the best bridge program in the world, which is on the BBO website, why it plays a good game 98 or 99% of the time, and then just goes totally nonlinear 1% of the time. So one shouldn't undervalue these achievements, but on the same hand, you shouldn't overvalue them. It doesn't necessarily imply that AI is now the technology that can do everything, because it's a very narrow scope, and this is a domain where it doesn't require common sense. It just requires the ability to compute something. And so let's look a little bit at AI, and there's basically two brands of AI, one which has really gone out of fashion and hence is now called good old-fashioned AI, GoFi, and the other one, machine learning. And the difference is that GoFi, the focus is on knowledge, and the machine learning, the focus is on learning. So GoFi systems build symbolic knowledge representations, in part the knowledge is done by eliciting knowledge in particularly structured ways from humans, and by having reasoning engines which compute over these knowledge bases. And in some cases, this is encapsulated in what's called expert systems. And AI has gone through various waves of enthusiasm and disenchantment, which have been known in the field as AI winters. And so there was an AI winter in the 80s, and then expert systems, people were very enthused about that. And then it seemed to run out of steam, leading to another AI winter, because first of all, expert systems were very, very hard to create. And secondly, they were very brittle. In a way, it's like the bridge program that I play with sometimes, that it breaks in unexplainable ways, in ways that are very strange. The other philosophy that pioneers such as Jeff Hinton have been working on for 30 years, but that go back to actually 50 or 60 years ago, there was a man named Rosenblatt and a neural net-like technology called perceptrons that he was already working on, and that fizzled out. But in the last 30 years, deep learning based on neural nets, which are incredibly, I'm sure everybody in this room knows more in detail technically about neural nets than I do, but the idea is that these networks are trained on examples of what they are and what they are not, and as the nets try to improve their performance by adjusting the weights on various neuronal-like elements, they get better and better. And this is typically called supervised learning, and there's also a lot of work now on what's unsupervised learning, as in that Go example where the net can learn without examples. And this has gone from a craze to insanity. There are tens or hundreds of billions, I was going to say tens, and then I thought maybe it's hundreds of billions of dollars now being invested annually in this. There's a city in China, that's investing, I think it was 1.5 billion a year for a number of years in order to build an AI industry. And we know here in Toronto, there's the Vector Institute and a lot of federal money. And everybody's on this bandwagon in order to create intelligent agents, smart systems that will do a variety of things. And in fact, the applications are widespread. So media processing is an example that people in AI and in particular learning systems have worked on for some time. And we now know that in part because of the ability of these systems to be trained on millions and tens of millions and hundreds of millions. An example, speech recognition has now gone to the point where it's essentially usable. I'm still blown away by some of the bizarre things that Siri thinks I have said to it, but still, for me, and I'm now able to send texts with far more detail than I was in the past, because even though I sometimes have to correct it, and the error correcting capabilities of Siri are abysmal, you'd think that it would be smart enough if I said, no, wait a second, back up, that it wouldn't simply recognize that as no, wait a second, back up. But still, the achievements are remarkable. Face recognition now being used commercially on an iPhone. Going into areas that have more ethical issues around them, judgments and decisions about human potential. Many resumes now, particularly by large corporations that get huge numbers of resumes, are not seen by a human unless they first have passed a threshold of acceptability done by a deep learning system. and these thresholds typically will throw out 80-90% of the resumes. Another area that I'll talk about a little later is criminal justice, where a very important and practical question that people in the justice system often ask is someone who has committed a crime in the past and who's now looking for some ability to lead a more normal life, what is the likelihood that they will recommit a similar crime? And this is an area where making decisions that are wrong on either side can be harmful. There's a huge amount of deep learning work on medical image processing, including cancer detection. I've already mentioned self-driving cars, and the applications in warfare are significant. And again, here's one where all sorts of ethical issues arise. In a sense, I'd rather send a robot off to fight a war than a human. On the other hand, the issue of how much decision-making drones and robot soldiers should be allowed, and, for example, what is the extent of human control over that, are important ethical issues. So let's talk about intelligence. I went and looked at classical dictionary definitions of intelligence, and they're sort of what you would expect. The capacity to acquire and apply knowledge, capacity for learning, reasoning, understanding, the ability to acquire and apply knowledge and skill. So these are definitions of intelligence that fit with the notion that a good chess player is likely intelligent, or someone who gets all A's in school is probably intelligent. But in looking about intelligence, I thought that maybe there were deeper concepts, and so I looked at the work of two psychologists, a Yale cognitive psychologist named Sternberg, who published a book about 20 years ago, in which he proposed what he called the triarchic theory of intelligence. And the two relevant definitions in this are what he called this contextual subtheory, in which he said intelligence is purposive adaptation to and selection and shaping of real-world environments relative to one's life. Okay, so it's adaptation to the environment. And his second subtheory was the ability to deal with novel tasks and situational demands. And of course, this is, if you think about self-driving cars, this is a critical issue with self-driving cars. What happens if all of a sudden there's a bicyclist on the right and another bicyclist on the left, and you know, a dead squirrel on the road or something like that? Has that situation been seen? The other psychologist whose work I thought was interesting is a Harvard psychologist named Howard Gardner. And this was a theory of multiple intelligences, and this has had a reasonably significant following in the research literature. And in his original book, since then his later books have talked about, well, maybe there's an eighth intelligence and a ninth intelligence and a 10th intelligence. But his earliest book asserted that the kinds of intelligence we measure in school are what he would call linguistic and logical mathematical. Then there's a set of intelligence which are useful in the arts: musical, bodily, kinesthetic, and spatial. But the two that I thought were particularly relevant in the context of the issues I'm concerned about are interpersonal intelligence, i.e. understanding people's intentions, motivations, desires, in other words, the ability to work effectively with others, and intrapersonal intelligence, the ability to understand oneself, have an effective working model of oneself. to use effectively to run someone's life. And so the question is, given these definitions of intelligence, what do you think? And I'm now going to throw it open for any comments. Anyone want to argue that AI systems that you've currently seen or used are intelligent or are not intelligent, or want to add something to this?
I think self-awareness is more apparent and real in humans. Humans think they know why they're thinking what they think, but they're wrong usually.
Okay.
I think you were setting that up as an important difference between us and AI, and I think it's a bit shaky.
Okay, I really want other people to jump in. This is my break while you talk for, yeah.
So for the Gardner's theory of intelligence stuff, right? So I'm not sure that making the move towards sort of a Gardner-style thing quite addresses, like, well, our definitions of intelligence, and then also just within sort of psychology on its own terms, it's not particularly in favor that empirical evidence seems to support our more traditional notions of intelligence. So we can say, well, it seems like your point here is that, well, we have this, there's stuff that intelligence test measures, and maybe there's positive correlations with, interpersonal stuff and some of the other things that Gardner wants to talk about. But really there's, other things that are maybe cognitive that are important, and other things that are, just important stuff about humans and society and interacting with stuff that are not, represented well by, intelligence in sort of the classic fluid intelligence sense, right? Like just ability to reason in novel situations, right? Is that about right, or?
Clearly, the issues that Gardner talks about, particularly in interpersonal and intrapersonal, are not dealt with well with classic measures of intelligence. And to me, they're even granted Hughes' comment about humans, I believe they're important in terms of thinking about the kinds of creatures that we want to entrust critical aspects of our life and people's lives to. Yeah, another comment somewhere? Yeah.
Well, I'm just talking about my understanding of intelligence. Towards computation intelligence, it seems to be the ability of collecting information and then to solve information-related problems. So when compared to human being, a lot of decisions we make is somehow not entirely rely on the information we have. So there's like
Well,
this.
yeah, by information, presumably you're talking about information that's input or brought to bear or stated with respect to a problem. And I think what you're stating is we bring a lot to bear that's implicit in that. And again, one of the questions or challenges for AI, I mean, I'm not trying to stop AI research, not that I could, but what I'm trying to do, and we'll get to this in the second half of the talk, is suggest issues that I think AI researchers ought to be thinking about, some of which I know many are thinking about, where I think the kinds of insights that HCI people have would be helpful in terms of those decisions, thinking about those issues. Okay, so let's move on. So I'm going to talk about 5 or 6 different things. The first one is anthropomorphism. I personally believe that it's important to know whether you're talking to an algorithm/machine or you're talking to a human. I don't know whether everybody agrees with me. We are now faced with an increasing inability to know what we are talking to. And the best example of that, or one example of that, comes from computer animation. So it goes back to an area that I worked in almost 50 years ago. So let's look at, and there's something called the Uncanny Valley. The first one is not a good understanding of the Uncanny Valley because it's so bad, even though it was put online a couple years ago, that you know that this is a machine.
Hello.
Nice to see you.
What is your job?
I am a social companion. I can speak of emotions and I can recognize people.
It's not showing up.
Officially the Republic of Singapore,
Oh, great.
often referred.
Okay, let me. Let's see.
Two as the Lion City,
Okay.
Garden City, and the red dot is
You have to get out
Pardon?
of presentation mode.
Yeah. Okay.
the leading global city.
Okay. Yeah. Now drag the window now. Look at that side. Wow. Must be okay.
Sorry, I can't. This appears on the screen so small that I can't see it.
So which one is the video?
Well, I want to show these three videos.
It was playing.
I will be just as bad as Ron.
If it's playing already.
It's playing into.
It's some window.
Yeah. Ain't wrong.
This one is a slide.
Oh, yeah,
Unless
there
it's a
we go.
tab.
There we go.
Is it the one
Yeah,
Full screen.
from the beginning?
yeah.
And full screen.
Yeah.
Full screen.
Yes. Be funny.
What is your job?
I am a social companion. I can speak of emotions and I can recognize people. We're officially the Republic.
Okay, so that you can see how bad that is. On the other hand, if I can get these other two, which Professor Mike Vandepan just sent to me. I thought I had tested this out beforehand, but clearly.
It's on screen. Put it in the tabs. Be good if it was in the subtabs.
I can.
Highlight the.
No, the resolution you should see on the screen is really tricky.
We can tell.
Yeah.
That left box.
No. I don't know what I agreed to.
That's fine.
Probably
Yeah.
something.
That's one that I want to see.
This
That
one?
Yeah.
Put the other one on.
Hello, I'm Siren, and I'm a digital human. I was created by an international team of artists and engineers who wanted to challenge our ideas of what a synthetic human could be. I've got state-of-the-art real-time graphics and an unprecedented level of detail in my eyes, skin and hair. Cool, right? But I'm more than just a collection of fancy pixels. I'm actually
Okay, I want to get one more.
Tomorrow, and tomorrow, and tomorrow creeps in this petty pace. From day to day, to the last syllable of recorded time. And all our yesterdays have lighted full.
Okay. Now I can get back to this. That'll teach me to show videos. I've been doing this in talks for 50 years and it hasn't gotten any less airplay. It's amazing. Okay, so I would argue that there are areas where it's important to know whether you're talking to a machine or a human. One example I would give would be a teen hotline. I don't know whether there's teen hotlines that are staffed by machines yet, but if there aren't today, there will be. And so the research opportunity here is ways to show gracefully that an AI is not human. Now, maybe that's nothing more than at the beginning saying, by the way, I'm not human. But anyway, the next area, and this is perhaps the most interesting and the most difficult one, is how do we know what a machine knows? This is an area that concerned AI researchers in the GoFi days, the good old-fashioned AI days, particularly researchers who were working on medical applications, because they wanted to know if an expert system said X, I believe the diagnosis is, or you should prescribe Y, to understand why the expert system has made that. This has gotten far worse with neural nets, because the notion that an explanation would be looking at tens of thousands or hundreds of thousands of weights is ludicrous. So what's required is for a machine or an algorithm to explain itself, and if it cannot explain itself, for users of the machine to be able to somehow understand how the decision is being made, what the logic of the decision is, if there is a logic. And so this is critical, particularly in areas like medical diagnosis. And another example is gender recognition. There's been some fairly well publicized research done lately that shows that algorithms that try to detect gender do very well on white males and do less well on white females, and less well on black males, and even less well on black females. Why is that? What is there in these algorithms or in the data that seeds them that results into this? And so the opportunity, I believe, for HCI research is to work with AI researchers in trying to make it understandable what an algorithm knows and doesn't know, how it makes its decisions, and perhaps what decisions didn't it make. Now, luckily, DARPA, the Defense Advanced Research Projects Agency, which has funded computer science research from the earliest days, including the early development of the ARPANET, which led to the internet, etc. DARPA actually also recognizes this as a problem because they want to be able to ask their drones, why did you shoot so-and-so down, etc. And so DARPA has a program called Explainable AI, and DARPA is now spending $75 million US over 5 years on this topic. So, as I say, there are thoughtful people in the AI community who are concerned about these issues. The next area I lump together in terms of trust and responsibility. And the basic question is, do we trust the algorithms that we are ceding power to, or thinking about ceding power or authority to? And at some extent, you have to ask yourself, what's the basis of trust? Under what conditions do we trust people or beings or things? I mean, we trust cars, so we do trust equipment and machinery at times, or we trust cars up to a point. And what's interesting to think is, how do we calibrate up to what point do we trust a car, and when do we distrust a car? And think, for example, it needs to go in for service. And I would contend that thinking about things like these, applying it to the area of AI will be useful. If you trust something, you give it responsibility, you give it authority, you make it accountable. And so the issues of when you don't totally trust it, or when all of a sudden it's done something that betrays your trust, it has, for example, as in the case of self-driving cars, where Uber recently had the first reported death from a self-driving car. And again, this was a case where there was a human supposed to be in charge, but it was ineffective. If there are mishaps, who is responsible? Is it the programmers? If it's a machine learning system that is learned on data, is it the data scientists who gathered the data? Is it the firm that developed it? Is it the person or the company or the organization that said, we want to use this for this purpose? And so, once again, I would contend there are opportunities for HCI researchers and UX people to work with AI people to show how decisions are made, to show what outcomes are of decisions under certain circumstances, and to help describe relative roles of relevant stakeholders. And of course, this is, I believe, going to lead to a lot of interesting innovations and battles in the legal front in the next 5, 10, 20 years. Two more, empathy. If we deal with the justice system, if we deal with medical specialists, we expect that there be empathy. In other words, we're expecting that the people we're dealing with have the ability to put themselves in our shoes and use this in some extent to influence the way they behave and interact with us. How does this happen with intelligent agents, with machine agents? How would they or could they understand people, and how could they communicate their understanding and use this in part as a role in their behavior? One area that where there has been a lot of work on what's called user modeling, machines understanding its users, is intelligent tutoring in the computer-based learning field. But there's still a large need for additional work here. And again, there, I believe, are opportunities for HCI research to work with AI researchers in enabling computers to have empathy and enabling a thoughtful consideration of situations where a slight change in input causes a dramatic change in output. And one example is insofar as algorithms are used in the judicial system, slight change in input causing, okay, guilty or not guilty, back to jail for 5 years or release on probation. And the final area is what I call justice. Can machines dispense justice? There is a lot of concern now in the AI community and in people thinking about the thoughtful development of AI in terms of bias that might exist in what are sometimes called quantified cells, the machine's encapsulation of people as a series of numbers, as a series of criteria. And so how do we understand the hidden biases in the data, and how do machines communicate those biases, and for example, showing how their decisions might vary under similar circumstances? And one area that again has been in the news quite a bit is the area of predicting recidivism, where there's a lot of evidence now that black defendants who have committed crimes, this is data is primarily in the U.S., black defendants are given or rated higher as a probability of committing a crime again than white defendants or white criminals in similar situations. And so the opportunity again is to work with AHCI in, for example, looking at how decisions are made as part of a family of similar decisions. So in summary, AI is everywhere. Is it really intelligent? I don't think we're going to decide today, is it really intelligent? It certainly betrays some signs of being intelligent in many circumstances, but it's got a long way to go. And I believe that if people are looking at AI and HCI for new areas of research, working with AI researchers in looking at some of these issues is a useful thing to do. So that's really all I have to say. I'm trying to, as I get older, talk shorter. So I guess we have about 15 minutes left. So I'm happy to take questions, comments, discussions. By the way, I should have asked this at the beginning, how many people here consider yourself as part of the HCI field? How many people here consider that you're part of the AI field? Okay, good. Well, we've got 2 or 3. I won't ask where everybody else comes from. But, okay, so thank you, and the floor is open for questions, comments, etc. Yeah, well, let me, okay, over there.
Just in terms of the last part there, in terms of the hidden biases in data, could you speak more about what you mean in terms of hidden biases in data? Is that sort of the people developing the algorithms might skew the data themselves to get...
Well, I'm not asserting that they're skewing the data. What's often or sometimes been asserted as where the biases come from is the data is intrinsically skewed because it's based on patterns of data that now exist in the world, and there's certain biases in the world, and they get reflected in the deep learning algorithms. And so the issue is, how do you detect what those biases are? And I don't have, I'm not here because I have an answer to that. I'm here because I'd like to get an HCI person working with an AI person on this topic. Yeah, David. Yeah.
It's very interesting that the problems you isolate as defining issues for artificial intelligence are also critical issues in the study of human intelligence. So, for example, and especially human intelligence in educational contexts. So, for example, one of the big issues in student learning is learning to give reasons for your answer. Do you remember when you were in school and the teacher would always say, give reasons for your answer? That's a real problem. The students often volunteer an answer, but they're really pressed to come up with reasons for it. And if they do come up with reasons, they still have a difficulty in coming up with good reasons. So these metacognitive issues that you're dealing with in AI are the very issues that studies of human cognition are trying to come to.
That's about, thank you. By the way, that's David Olson, a distinguished emeritus prof, applied of psychology and education. Yeah, back there.
I want to build on that point because I've had the opportunity to be in the justice system. And the first thing I noticed was the incredible subconscious bias. And I started reading all about bias. And then I started trying to figure out ways to counter the bias and play with the bias so that I could turn it to my favor. And so I just want to build on that point and say that it really comes into play with the bias. It's very subconscious. It can be conscious and subconscious. And at least at the algorithmic level, you can go through the data set and you can start to analyze it and say, oh, well, we don't have any of these kind of people in our data set, or we don't have any women in this data set, or whatever. You can start to actually address it in a systematic manner. Whereas the human subconscious, that's much more difficult.
Yeah, that is one reason to be hopeful in this area. As you say, we can pull out the data and look at it and say, aha, that's what the problem is. Okay, I'll get, yeah.
Okay. So speaking about the biases, there are examples.
Speak up, I'm having trouble hearing you.
So yeah. So speaking about the biases, there are historical example in the U.S. justice system that there are inequalities in the societies that are being amplified in the AI system. So do you think is it the problem of the artificial intelligence algorithm, or is it the problem in the societies that are being amplified in the way that the algorithms are being applied?
Yes, I mean, it's both. There are problems in society and there are problems in the algorithms of the data. The challenge is to identify those and address them.
You said you wanted to make synthetic human simulacrums, or whatever you want to call them, marked in some way that the observer can tell the difference. And I think that's great, but it's not in the interest of any of the people producing them. So the only way I can see that happening is legislation or a code of practice or something like that. And I mean, I would have argued the same thing, that every censor in our society that's aimed at the public should be flagged so the public knows it's there. Years ago, I used to joke that every video camera should have a happy face around it to highlight it, but that's never happened, and I think that's equally important. So do you think it's important enough to legislate, and you can convince
I think it's important enough to legislate it. I would like to know, and unfortunately I don't, whether some companies have agreed that it's important and had their intelligent agents identify themselves as intelligent agents rather than humans. What I fear is that then most people would have done what I do, which is press 0, hoping you can get a human. But it's an empirical question. I mean, could you, by leveling with the public, get a greater degree of user acceptance? Yeah.
I very much appreciate the parallels between education assessment of student learning and the artificial intelligence. It's one collection of data set, it's one perspective, and it's designed by one particular person, and it could change very, very easily. So I appreciated that and the bias.
Yeah.
There's a question that you didn't quite touch upon, and I think is important for us to ask ourselves. Why do we want artificial intelligence, and where we want it, and whether we want it or not? I like a lot your example of the self-driving cars, which raise more problems, it seems, than it resolves any. You talked about the driver not being able to intervene fast enough when they understand the problem. I see all the problems as a pedestrian. I don't know what the machine thinks when I want to, cross the road, because the car itself is not providing any feedback. When I interact with a real human driving a car, I can make eye contact and assess whether this person saw me, and then I can cross or not confidently. And so it seems to me that we are trying to put AI in many and every types of, areas and so, and maybe it's not the one solution. And is it always appropriate to go towards this, have this urge for AI for all problems?
It isn't always appropriate, but we live in a capitalist world, and decisions about allocation of resources are made by the owners of corporations, primarily. They argue for the benefit of their shareholders, not to mention themselves. And so if they think they can save money, in particular by replacing humans with machines, they're going to do so. And there's doesn't seem to be any governmental forces that are able or can reasonably counter it. Now, the self-driving cars thing is interesting. in that case, I don't believe it's because a company is trying to put people out of work, although maybe in Uber's case it is. Maybe they'd like to get their cost of transportation down to the cost of goods served down to nothing. But it's being done, I believe, in part because it's a technically sweet thing to do, and AI researchers are having a ball doing it. And the other argument in terms of social utility is safety. And despite, there will be a series of people who will die in the next few years, 5-10 years, with self-driving cars. But I personally believe that ultimately most cars will be driven by machine, and the social benefit is that fewer people will die, because we just, and truck drivers are going to be deeply hurt by this. But you look around at the number of major pileups and snowstorms that involve trucks, and you say, my God, here's somebody who drives for a living. Surely they should have the sense to slow down in snowstorms, but they don't. We just seem incapable of making thoughtful and ultimately rational decisions when we're driving. And so I'm personally regretfully in favor of self-driving cars, because I think it'll keep more people alive longer than them. Yes, over there.
I think in the past, software has augmented our intelligence in many ways, or at least tried to. But see this sort of, I think that's interesting from the AGI perspective. And in us, more so than it, just as.
Yeah, the notion of machines augmenting our intelligence is certainly one that I've been a great fan of ever since reading Licklider's paper Man-Computer Symbiosis, which goes back, I believe it was written in 1950, and it was one of the things that motivated some of my early work. So, absolutely, we can augment human intelligence with more and more clever AI, but this talk is addressed more at AI being developed in its own right, for its own sake, as a means of having computers and machines do things essentially on their own. And that's a very different flavor of activity than the one you're describing. Yeah, Kai?
I'm not sure I'm phrasing this question correctly, so bear with me. So you gave some numbers as to how much funding is going towards core AI in the tens to hundreds of billions of dollars. Then you mentioned DARPA throwing $75 million, which is several magnitudes less, right, at explainable AI. What do you think is going to be necessary for people to recognize the importance of the role of HCI with respect to making AI deployable? What's going to have to happen for us to see this rise in funding for HCI and AI?
I don't have a good answer to it. My guess is that the first few significant published results in which an AI researcher, for example, makes his algorithm explainable that incorporated HCI or UX design input, that's going to make people say, yes, HCI is an important component of it. But I don't have a good answer. I did write the program director for the DARPA program briefly, but I haven't gotten into a significant dialogue with him, and it's probably something I should ask him. And somebody, who was it? I believe Chris Collins at UOIT, is actually working on one of these explainable AI projects with people, I think at Stanford Research Institute or something. So there's at least one Canadian point of research going on here. Yeah.
Actually, I would argue that the AI is increasing the intelligence of human being. Definitely, actually, it's increasing the capabilities, but it's dependent on that technology. Let's take an example of GPS. In the past, people were able to find the address by looking at the map. Today, of course, like you find the address very quickly, it takes you there, but when you pull the plug, is this person's intelligence is like higher now? Can they find that address anymore?
Yeah, well, this is the classic problem. I mean, if you don't have a calculator, can you multiply large sets of numbers? Well, probably not, but maybe you should never have been able to do that. I rely upon GPS, but I try to ensure that I have a mental model of where I'm going in case of error. But it is, every stage in which machines have been used to augment or replace certain aspects of human intelligence, people ask the question, does that mean we don't have to do it ourselves anymore? I happen to have grown up before spell check, so I still know how to spell. But let's see. I'm trying to. Okay, everyone has spoken. Okay, back there. Yeah.
I was actually wanting to build on that point again because I was wanting to talk about that before you raised it, and that is the impact of AI on our own intelligence. So we're changing our brains, we're changing the physiology, we're changing the neuroscience, the way everything connects. And so it isn't just a matter of losing that task, that ability to do that task. We've reshaped our own, the minds of our children, for example. I think about their spatial reasoning with respect to a map, and they don't have it. And I wonder if you did an MRI of people like us, and we had to rely on maps for spatial reasoning, and you did an MRI functional MRI on the kids. And there's a back and forth, but you're actually changing the development of the human brain and all kinds of impacts on intelligence.
Well, I play far more hours of online bridge than I should, but it has made me a much better bridge player because of the amount of practice I've gotten against automated players that are good most of the time, and when they self-destruct, they self-destruct. And by thinking about what happens when I've done something right and something wrong, but that requires a level of metacognition that goes beyond maybe what our kids can do. So, yes, right there.
I guess in terms of education, like things such as having reading math or spelling, at least for me, I feel like I no longer can spell hard words without a spell check, unfortunately. And I think personally, I don't think that's a big issue. It's in the past, if you go all the way back to the ancient Greek, they'll go Socrates would argue that you should not write books or read books because you should have it all memorized. But I think having this enabling technology lets us free up space, not having to memorize phone numbers, not having to memorize math, not having to memorize to do more, I guess, higher cognitive tasks. And I think overall, in that sense, AI is good for education, right? Because it frees up, I guess, almost simpler tasks.
It frees up cycles to do harder stuff. Yeah. Okay. All right. It's a bit after 2, and I have a doctor's appointment I've got to. So thank you for your attention.